Okay guys, so this is your final opportunity to watch another model problem. This is extension question 2, and it's going to be sort of aligned to the extension we saw on the previous video, but instead of your information being presented in a table, this time you'll see we have information presented to us graphically. We're still addressing the same scenario with this equation of a tangent line business, so you can, again, I know this is feeling redundant, but anchor yourself in this template and fill in what you know. In this case, the x-coordinate is 1, which means I'm going to need to find g of 1, and that also implies that I'll need g prime of 1 for my slope. So g of 1, let me start with that. If I take this function g, I'm going to sub a 1 in where there are x's. So that means I need to find, or simplify 1 over f of 1. I was told at the beginning that this over here is a graph of f. So that f of 1 isn't bad. I go to the input 1 and our appropriate output is 2, which means that the y value associated with our input reduces down to a 1/2. The harder part is always the slope, so we'll start with our derivative, utilizing our quotient rule. I'd urge you to pause right now and try this quotient rule without my modeling to see if you're getting the hang of it. Turn the video back on once you have something that you can compare your work to. My work to is what I meant. The low function is f. The derivative of the high function is 1 minus the high function of x times the derivative of the low function, which is f prime of x, all over f of x squared. Hopefully that went okay, and now the big idea is to substitute in a 1. I've got f of 1 then, times that 1, I won't write that again, minus 1, I won't write that, times f prime of 1, all over f of 1 squared. So what we saw in the previous evaluation that we did is that f of 1 I was able to pinpoint right here on my graph. So I'm seeing that this f of 1 in the numerator I can replace with a 2. The f prime of 1 I'll have to think about a little bit more here in a minute. But down here I've also got just 2 that I'm squaring. So the big question then is, what is f prime of 1? Because if I can find that, I'll be set with my slope. So I'm remembering derivatives are just fancy words for slopes. And if I come over here at 1, I can see that this is a linear function of f. And so it's not hard to find the derivative because I'm remembering derivative is just code for slope. So when I look at this graph, I can see that I'm going down 1, and running forward 2. Therefore, my slope at that point on that line segment is negative 1/2. This becomes 2 minus that slope of negative 1/2 over the 4. Doing some math, that's 2 plus 1/2 over 4, or 5/2 over 4, or 5/2 times 1 over 4, or finally 5/8, which goes up here. And there's the equation of my tangent line. There is a follow-up right here I don't want to neglect. It says to then estimate g of 0.8. We've been doing this a lot. I'll write that g of 0.8 is approximately equal to 5/8 times 0.8 minus 1 plus 1/2. You've seen this enough to know that you're not impressing me if you do that math. Just box it up so that we don't run the risk of making a mistake.